linear functions and writing the equation of a line. We're going to do f of x equals mx plus b or y equals mx plus b. That slope-intercept form is what we're going for here. We're going to go about it two different ways. One way is finding a line of fit. And that a line of fit is just kind of eyeballing it. You're looking at it, and like you would look at the points on a scatter plot or plotted on a coordinate plane. You would look at those and then try to find two that look like it, was a pretty good fit, and then you would find the line using those two ordered pairs. The line of best fit we're also going to do today using the graphing calculator. So we're going to learn how to do linear regression with the graphing calculator. If you've never done that before, it's not very hard. But we're going to talk about how to do that today. So when we get to that, you might want to make sure you pay close attention to the buttons that we're pushing and all that stuff so we can get there. But with linear models, you've got basically four situations that can happen. And those are correlations that you can have here. And I'll try not to scroll too fast. These blue dots that you see plotted here are just points that will be given to you. They're the data points for our situation that we might have. And we've just plotted them, or I've just plotted them on the coordinate plane. On the first one on the left there is a positive linear correlation, because you can see that they all kind of go in the same direction. They all kind of follow a straight line there. You could put a line of fit through there pretty easily. It's very easy to see that that's almost a straight line with several of the points. You start here and go there. That's a lot of straight points in a straight line. But it's a positive correlation because it looks like it has a positive slope. It's moving up and to the right. So positive slope, positive correlation there, positive linear correlation in this case, because it kind of follows a straight line. One on the right, same kind of idea. We got all these dots here. They're representing ordered pairs, and they follow this kind of a linear path all together. Nobody's on exactly the same path, but there are several that would be close to the same path, and they fall from left to right. So they're going down from left to right, and that would be a negative slope, thus a negative linear correlation. So the slope and the correlation go together. Okay, so we got a positive slope up and to the right, negative slope down and to the right, and then situation number 3 would be a linear correlation with a zero slope. So it's constant all the way across there. Still a linear correlation in the form of a straight line, but it's straight across, so a zero slope on that. So that's situation number 3. And then you have another situation. This is kind of the wild card one, that it doesn't follow a linear path. This one, obviously, is not a straight line. If it's not a straight line, it's not a linear correlation. This one does have a correlation, but it's not linear. And in the first section here, we're talking about linear things, so that's what we go with. We'll get to this in the last section. We'll get something like that. Okay. So to be a linear correlation, it's got to form something close to a straight line, and then we need to be able to find a slope for that, and then eventually the Y-intercept for that. So we're going to use by hand and then use the graphing calculator to do that as well, and see how we can get there. So let's start with an example. Some ordered pairs. Okay, you got several of them here. You got 3, 0, 5, 2, 7, 3, 9, 6, 11, 9, and 13, 11. Okay, so nice, good set of ordered pairs. And we can use the graphing calculator to kind of help us get an idea of what kind of correlation this is. And I want to show you how to do that. Okay, so with the graphing calculator, before anybody starts, I want us to make sure all our calculators are ready to start. So hit Stat. Okay, and you should get to this menu. And then I'm going to hit number 5 for Setup Editor, and then hit Enter. What that does is it resets your stat menu so that if for some reason you've got one of the lists not showing up on your calculator, it puts it back. So if for some reason you had a list that disappeared, it'll put it back, and everybody's is set to the same place now. So you don't have to do that every time. I just try to do that the first time so that everybody can be on the same page when we start. All right, so the next thing to do, or the first thing that you want to do, is you want to put in your ordered pairs. So you're going to hit Stat, and then under the Edit menu, you're going to select Edit. Okay, I'm going to write that down. Stat, Edit. All right, Stat, then Edit. Now, I've got a couple of lists that are already in there. I want to get rid of those. Okay, so to delete a list, press the up arrow until that list number, L1, L2, whichever list you're in, until it's highlighted, and then hit clear and enter, and it'll delete the whole list. I'm going to do the same thing on list 2. So press up until L2 is highlighted, hit clear and enter. If you've got something in list 3, 4, and 5, don't worry about those. If it's bothering you, you can go ahead and clear them. But we're only going to be using list 1 and 2 because we only have X and Y values. So that's the only 2 lists we're going to use. So list 1 is going to be our X values. So enter or input X values in L1. Okay. So 3, 5, it's the odd numbers from 3 to 13. 3, 5, 7, 9, 11. So I type the number and then hit enter and it puts it in there. Okay. And then we're going to input Y values in L2. Okay. L2, the Y values were what? 0, 2, 3, 6, 9, and 11. 0, 2, 3, 6, 9, and 11. And it does matter if they're in order, like paired up ordered pairs. If they're not in order like the ordered pairs are, then you're doing something totally different. Okay. They've got to be in order as the ordered pairs have them in your table that they give you. Okay. All right. So we don't know for sure if that makes a linear correlation. We want to make sure of that. So what we want to do is use our calculator to draw the scatter plot. Instead of us having to take graph paper and make a grid and plot all these points individually, if you had 20-something points to plot, that takes a little while to do. Doesn't take quite as long to type them in here and then get your calculator to generate that scatter plot. So we're going to do that. So what we want to do is press second, quit, get back to the regular calculator screen. That way everybody's at the same place. And then we're going to hit second, Y equals. Okay. Second, Y equals. And that gets you to the stat plot menu. Okay. And we just need to turn one of these stat plots on. If you have more than one of them on, you need to turn the other ones off. I'm going to use stat plot 1. I'm going to hit enter on number 1, and then I'm going to tell it to turn that thing on. And then on the top, make sure the first selection is highlighted. That's the scatter plot selection. The next selection is a line graph, then a histogram, a couple of versions of box and whisker plots, and then a step graph is the last thing. But we want to use the first one, the scatter plot. X list, where did we put our X values? List 1, right? Make sure that says L1. If for some reason yours doesn't, then when you go down there, you can change that by hitting second and then number 1, and that'll put the list 1. Notice in blue above the number 1, it says L1 right there. That's how you change that list if you ever needed to. Shouldn't need to in this course here. When you go to a stats class, yeah, you might. There's a lot of different lists in there. Okay. And then Y list is going to be L2, should be the same. It does not matter which of these marks you pick. I always just leave it on the first one because it doesn't matter. Okay. You'd rather see plus signs instead of boxes, then you pick the plus sign. Okay. It doesn't matter. All right. So once you've done that, hit graph. And we notice I've got an equation in there and it's showing up. So I want to get rid of that. Hit Y equals, and there's something I graphed in Algebra 2 the other day. Okay. So get rid of that. But you'll notice we had several ordered pairs, 1, 2, 3, 4, 5, 6. But when I look at my graph, I'm only seeing 1, 2, 3, 4 of them. I'm missing a couple of them. So what I've got to do is adjust my window on the calculator. And the easiest way to do that is to hit the zoom. So zoom is in the middle, up at the top. And then the number 9 for zoom stat. What that's going to do is going to fit your window to fit the statistical plot that you told your calculator to make. And there's all our ordered pairs from our table. They make a linear correlation. Pretty much, yeah, it wiggles a little bit there in the middle, but it's pretty straight, right? So we see that that's a linear correlation. If I were going to do this by hand and find just a line of fit, I would pick up a couple of points and create my line from there. And I'm going to do that. We're going to do that with this point and this point. So the second one and the third, fourth, fifth one. Because I think that would be the line that gets the closest to most of them. So if I'm eyeballing it, I've got to pick 2 points there. If I ask you on the test or the Canvas quiz to do a line of fit by hand, I'll tell you which 2 ordered pairs to use. That way we don't have 12 different answers on it. We've only got one possible answer to do a line of fit. So I'm going to do it with the second one and the fifth one in the ordered pair list. So I'm going to use this one, third, fourth, fifth, and this one, okay? Don't forget it, graph, and then zoom 9, all right? That's the kind of the order of getting there for that. Okay, so we're going to find the line of fit using those 2 points. So first thing I need for a line of fit is a slope. So 9 minus 2 over 11 minus 5. 7 over 6. My slope is 7 over 6. Now I need to find B. How do I do that? Say it again. B is the y-intercept. How do I find it? If I had B in the equation, I could do that. But here I'm trying to find B. So I need to use an ordered pair. I need to use one of those I used for the slope. Okay, so I'm going to use, so we're going to plug it in for Y and X there. So I would plug in 5,2 looks easier than 11,9 does. So I'm going to use it. 2, 7 over 6 times 5 plus B. Okay, so that's going to give me 2 is equal to 35 over 6 plus B. I would subtract 35 over 6. 2 minus 35 over 6. 2 minus 35 over 6. Math, enter. Just get it as a fraction. Negative 23 over 6. So B is negative 23 over 6. So my equation, my line of fit equation, line of fit for this problem is Y equals 7 over 6 X minus 23 over 6. That's the line of fit. Let's find the line of best fit with the calculator. Slide this stuff down here. And let's slide everything. I don't want to just slide part of it. I don't want to slide all of it. Get up and move it. All right, so with the calculator, I've already done all the hard work. I put the points in, and I've got the scatter plot done. I just want to find the line of best fit for that. So that's an easy thing to do. With the calculator, you hit stat. So for the line of best fit, we're going to hit stat over to calc. So right arrow to calc. And then we got all these things your calculator will do for you. One variable statistics, that's used in a stats class. That finds you like mean, median, all those fun standard deviation, all those fun things. two variable stats. That's if you got two variables and you need to find all those things about two variables. But we want number 4, linear regression, LIN-REG. Look at the out beside it. It says AX plus B. Notice that number 8 is also linear regression, and it says A plus BX. It's just in a different form. It's exactly the same equation, just not in the form we want. We want this form, so we're going to use that so we don't have to do anything else. Okay, so we want number 4 for linear regression. And if you're using an 84 plus with the latest operating system, it's going to do this. It's going to ask you, where's your X list? Where's your Y list? If you had a frequency list, you won't have that in here. That's like a frequency list would be a third column in that ordered pair, and it would tell you how many times each ordered pair showed up. We don't have that here. So that leaving that blank. And then it also asks you if you want to store the regression equation. You can. It's not necessary that you do that. It takes several button pushes to get it to store something in one place. You might as well just write it down and use it. It's quicker to just write it down. Okay, so if you're using an 84 plus with the latest operating system, it does all those things. If you're using an 83, you don't have to do anything but hit enter. With the 84, everything should be defaulted to that, and you just arrow down to calculate and hit enter, and it spits out our equation saying that A is 1.1285, blah, all those numbers. B is -3 point stuff there, okay? And we're going to round 3 decimal places. Looks like a good place to go. So it would be Y equals 1 point, how much? 129 is the slope. The Y-intercept, -3.862. And that is the calculator cranking out the linear regression, the line of best fit. What it does is it does a ton of calculations on how far those plots are, those ordered pairs are from a line of best fit, and finds the smallest one. So it would graph it. Yes, absolutely. Well, it wouldn't go. This wouldn't go through those 2 dots.
Okay.
It
would just the best.
It would be the closest to all of the dots.
Okay.
This one that we did by hand, where I wrote that would go through those 2 dots.
Okay.
This one might not. It'll get close to it though.
Okay.
This one will get as close to all of them. This one is definitely going through the 2 dots we picked, and they won't be. They usually are not the same. Okay, because I mean this is pretty close to the right Y-intercept, because -23/6 is 3 and some change, right? And then 7/6 is 1 and some change. We got pretty close with that one we did by hand. This one's better because it calculates the closest to all of the points, not just the 2 you pick. Okay.
Can you go over one more time the calculator for it? I missed.
Sure. All right. So to find the line of best fit, you're going to hit the stat button, and then press the right arrow key to get to the calc menu. So we're hitting stat, right arrow key to get to the calc menu. We should be choosing number 4. If you're using an 83, I'm not 100% sure that it's number 4. It's been a while since I used an 83 in hand. Sometimes they're in a different order depending on what operating system. It may be number 4. Either way, you're looking for LIN-REG. Pick that. Everything should be set the right way. If it's not, set it there this time, and you won't have to reset it again. Okay, so list 1, list 2. I'm going to hit calculate. And depending on which calculator you've got, which operating system you're using, if it does that menu system or not. Because I think the latest operating system is like 2.55 for the 84s. And it came out a couple of years ago. They hadn't updated since then because they came out with a new, more expensive calculator. So why would you work with the old ones? That's their view anyway. All right. That get you? We're going to do another example, so you'll get another shot at practicing. So, all right. And then we'll do some quadratic regression later today. All right. So we've got another set of ordered pairs here. Let's do 2 things. Let's find a line of fit by hand, and then we'll do a line of best fit. Okay, so that, edit, and then list 1 and list 2, I'm putting X's and Y's. So clear those out. And don't forget to clear out a list. You hit clear, and then you have to hit enter for it to take it. -2 to +2. So -2, enter, -1, enter, 0, 1, 2. The X's are pretty regular. There. The Y's 76320. 763 76320. Second quit. And then how do we get it to plot that? Second Y equals. Make sure a stat plot's on. Make sure it's set everything the right way. It shouldn't have changed any. And then what? Graph, zoom, 9. Good job. What kind of correlation do we have here? Negative linear correlation. Pretty close to a straight line, and it's a negative slope. We can see that. If you don't hit zoom 9, your picture won't look the same. Okay, so zoom 9 is kind of an important part there. All right. Now, let's pick a couple of ordered pairs that we think would get us a good line. I'm thinking this one and that one, the first and the last, gets the closest to all of them. So let's use that to do the one by hand. So let's use -2, 7 and 2, 0 to find the line of fit. Just the one by hand. So first thing we do to find it by hand is slope. 7 minus 0, -2 minus 2. The 7 over -4. And pick a nice ordered pair to plug in there. I'm going to use 2, 0 this time because I like, the 0 in there. It looks like it's got to be easier. The -7 over 2. And this would be +7 over 2 is my Y-intercept. So my line of fit is Y equals -7/4 X plus 7 over 2. We could graph that and we would see it crossing through those 2 points that we picked. And then the easy thing is the line of best fit. You just punch the buttons and it does it. So what buttons do we punch? Stat. Calculate. Right arrow to get to calculate. 4 for linear regression. Everything should be set up for me to just tell it calculate that thing. And we get -1.8 as a slope, 3.6 as a Y-intercept. 1.8 X 3.6. Is that right? Yeah. No need to round that one. They came out to be exact values. If we wanted to graph that and see how well it fit, we could just type that equation into Y equals. Tell it to graph it. It goes and it does it for us. Nothing too spectacular about that. Now, you could use that equation of regression. You could use it to predict what's going to happen when X is a different number. So that, if you wanted to predict if this is some sort of data for a word problem of some sort, and they wanted you to predict what's happened when X is 20, you could plug a 20 in for X and get the answer. That would tell you what it's a prediction equation, really, is what you're building there, is to predict what's going on. All right? Not much else to it but that. All right? Next section, a little bit more involved. We're going to talk about quadratic equations in section 4.3. Quadratics. Quadratic functions, actually. Quadratic functions. What's a quadratic function? Parabola. That's what the graph is called, absolutely. All right, quadratic functions, parabolas. They look like this, or flip them over and they look like that. Those are parabolas. That's the shape that we're going to be seeing. Standard form of a quadratic, f of x, y, same thing, ax squared plus bx plus c. A, b, and c are just numbers. Okay. Now, in that, certain parts of the a, b, and the c tell you things about this quadratic. If it's in that form and a is greater than 0, what kind of number is it? If a is greater than 0, it's a positive number. What that tells you, it's going to open up. And that would be this direction. It'll look like that. And that also implies that you have a minimum. Okay. A being positive tells you that it opens up and you have a minimum, which is the lowest point on the graph. If A is less than 0, guess what it does? Puts down. And then you would have a maximum. It opens down. Okay? That minimum or maximum is called the vertex. The minimum or maximum point on the graph. The domain for a quadratic function, negative infinity to positive infinity. The range depends on A. And essentially the y value of the vertex. If A is positive, then your range would be from the y value of the vertex to positive infinity. If A is negative, it'd be from the y value of the vertex to negative infinity. Those sort of things happen there. Okay, so some important parts that we're going to talk about here with quadratics. If you took Algebra 2 recently, in our particular textbook we use at our school, it's chapter 4 in Algebra 2. Talking about quadratics, I think is right. I think it's chapter 4. 4 or 6, one of the two. I can't remember. We changed books a couple times. So, axis of symmetry is the first thing that we find. It has a nice little formula. X equals negative b over 2a. So that's that a, b, and c from standard form. Okay. From that, we can get the vertex. And the vertex is an ordered pair. The x value of the vertex is negative b over 2a. The exact same value from the axis of symmetry. So you get 2 for 1 on that deal. And then to find the y value for the vertex, you just plug that number in for x and work it out. F of whatever negative b over 2a is. Negative b over 2a is the number 5. You plug 5 in for x and work it out. And that gets you the y value for the vertex. And the vertex is an ordered pair. The axis of symmetry is an equation, x equals negative b over 2a, whatever that ends up being as a number. Okay. The vertex is an ordered pair. when you talk about intercepts for a quadratic, the y-intercept, if it's in standard form, it's always 0, comma c. Every single time. Or you could just plug 0 in for x. That's what gets you that happening. 0, c is the y-intercept. The x-intercept, or x-intercepts, depending on the problem, that means you're going to set the function equal to 0 and solve. Now, there's a few different ways to solve. We're going to talk about a couple of them today. One of those ways is factoring, and we'll look at that a little bit. And then the other way that we'll talk about today is quadratic formula, which may be the most popular way to do it because it always works. Factoring doesn't always work. Not every quadratic will factor, but every quadratic can be solved using the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2a. In my class, we sing this to the tune of row, row, row your boat. So it goes x equals negative b plus or minus radical b squared minus 4ac divided by 2a. And you helps you remember it. My kids remember it. And kids I had 4 years ago will come to my class for college algebra. And we get to this section, and you'll hear them humming it as they're doing their problems. So, but you'll remember it that way. So row, row, row your boat. You get the formula there. So if you can remember that tune, practice it. Go back and watch the YouTube video, and you'll get a nice tutorial on singing it. Inside of that, there's this important part here, and we're going to highlight it. That b squared minus 4ac. That thing right there is called the discriminant because it discriminates what kind of answers you have. Okay. Discriminant b squared minus 4ac. All right. If that discriminant is less than 0, that means it's what kind of number? Well, we will end up with complex numbers, imaginary numbers, because you're taking the square root of a negative, right? So if what's under the square root is a negative number, then you're going to have complex solutions, which means there's no x-intercepts. If you have complex solutions, that means it does not cross the x-axis. Okay. If b squared minus 4ac is equal to 0, that means we're taking the square root of 0, which is 0 all the time. That's one x-intercept. Yeah, good job. True. A little more detail there is if the y-intercept or the discriminant is 0, then the x-intercept will be the vertex. That's where it will be touching the x-axis at the vertex. And then the other option is if it's positive, that means we have 2 x-intercepts. So we're going to build quadratic information here based on that. So once you find all these things, axis of symmetry, vertex, intercepts, all of those things, that's what we're going to find about quadratics. And then in the last section, we'll talk about building a quadratic from a set of points or a question. So let's take an example here for this section, and let's just take a nice quadratic that's already in standard form, a pretty easy one, and we'll talk about how you can solve it and do all those things. So the first thing we're going to find is the axis of symmetry. Axis of symmetry. So we've got to know what A, B, and C are. If we don't know what those are, we're not going to be. I'll just say we're screwed if we don't know what A, B, and C are. Okay. So what's A? B. And C? All right. So we know what A, B, and C are. All right. So let's find the axis of symmetry. What's the formula for axis of symmetry again?
X equals -2
Negative B over 2A. And you can put that to whatever tune you want. It's short enough you could, get that easily. So negative B. So if B is 7, negative B would be -7 over 2 times 1. So our axis of symmetry is X equals -7 over 2. That's the axis of symmetry. What that means is if we graph this thing, we should be able to draw a line at X equals -7 over 2 and fold that parabola perfectly in half. That's what that means for axis of symmetry, is that we would be able to, we would have a parabola drawn here. We would, there's a parabola. That line where it's folded is the axis of symmetry. That's what that means. Okay, so nothing fancy about that. It's just good old-fashioned math. So X equals -7 over 2. That helps us because the next thing we want to find is the vertex. We already have half of it. Half of it is what? -7 over 2. Let's find the y value for that thing. How do we find the y value if we know the x value? Put it back in the problem, yeah. You got a nice $100 calculator laying there. Use it. Work that junk out. 49 over 4 minus 49 over 2 plus 12. I'll do it without the calculator because I have to have it. I'm just doing it without the calculator because I'm too lazy to pick up my calculator. -1/4. Is that right? That'd be negative 49 over 4 minus 98 over 4 would be 49 over negative 49 over 4. Negative 49 over 4 plus positive 48 over 4 is -1 over 4. So -1 over 4. So our vertex is at that point. Now, here's the I won't say $1 million question because it's not that hard. Maybe this is the $20 question if anybody ever watches reruns of Who Wants to Be a is it Who Wants to Be a Millionaire? That's the question. Is that a maximum or a minimum? And why, of course. A is what?
Greater.
A is greater than 0. It's 1. It's +1. So what way is this graph going to open? Up. So that means that vertex has to be at the bottom. So it's a minimum. Knowing that is kind of important. As in, there will be a test question about that. All right. So we've got axis of symmetry. We've got the vertex. Let's get the intercepts. What's the y-intercept? Zero 12, because it's 0C. Anytime it's in standard form, you just look at C, and that's your y-intercept. If you forget that, just remember to find the y-intercept of any equation you're ever given. What do you plug in for x? 0, and work it out. So no matter what equation we ever use, if we got a fifth degree polynomial in not next week, but the next, you need the y-intercept, plug a 0 in. You got the y-intercept. X intercepts is, they're not as easy. They're a little more difficult, okay? How do we find the x intercepts? Set the whole thing equal to 0. So I got x squared plus 7x plus 12 equals 0. So we got a couple of options here. Factoring is an option. We're going to show that. We're also going to show quadratic formula. This one will factor. So if you haven't factored polynomials in a while, I'm going to show you how I teach it, and hopefully you catch on to it. If you don't, then shoot me an email. I'll shoot you just some videos that are going to show you how, because I've got a lot of them out there. So factoring, I use this method called the X method. And the way you factor a quadratic is you take whatever A is times C and put it up top. 1 times 12 would be 12, right? And then B always goes in the bottom. And it's just a way of organizing the thinking. When I learned to factor in high school, I learned it by guess and check. And guess and check works. If you learned it by guess and check and you're good at it, keep doing it. But I don't do it that way anymore because you guess which one, you make yourself two factors like X and X, and then you guess what numbers go in there. It's not very dependable. If you're good at you've got good number sense, you get it by at least the second or third try. But if you're not really good at multiplying, you're not going to get it ever, usually. So this method works pretty good because we're looking for numbers that multiply to be the top number and add to be the bottom number. So that narrows it down from every number in the world to just a few numbers that multiply to be 12. So our options for multiplying to be 12 would be 12 times 1, but 12 plus 1 is 13, not 7. So that's out. 6 and 2. 6 times 2 is 12. What's 6 plus 2? 8. Closer, but still not the right number. 4 times 3 does multiply to be 12 and add to be 7. So those are the two numbers that I'm going to use. And I fill in my X because, can't leave anything undone. 4 and 3. And because there's a 1 in front of the X squared, I can go straight to X plus 4 and X plus 3. If there's anything in front of that, I can't do that. And then I set each of those factors equal to 0. And solve them. You just change the sign. So my X-intercepts are at -4, 0 and -3, 0. And that finds me all my intercepts. If I wanted to do the same problem with quadratic formula, it works every time. Not every quadratic will factor. So you've got to be able to work on some that factor and then work on some that don't factor. Quadratic formula does that for us. It's x equals -b plus or minus radical. And then b squared minus 4ac. So 7 squared minus 4 times 1 times 12 over 2 times a. That's the quadratic formula. X equals -b plus or minus radical. B squared minus 4ac divided by 2a. So that works. This is going to work every time if it's in standard form. If it's not in standard form, you got to put it in standard form. 7 squared is 49. 4 times 12 is 48. Square root of, or 49 minus 48 is 1. So we really just have the square root of 1 right there. And I hope we know that. What's the square root of 1? 1. So we got two problems. -7 plus 1 over 2. -7 minus 1 over 2. That'd be -6 over 2. That'd be -8 over 2. Guess what? That's -3 and -4, just like I found by factoring. I get the same answers. -3 and -4. That's the same answers I got by factoring. Factoring works great. Factoring is something we're going to have to be able to do, but quadratic formula will get you the same answers when you're looking for intercepts. If we're trying to break a polynomial down, factoring is going to be just a necessary skill. We've got to have it. We'll work on that some as we need it more. All right, so we've got all that information. We also need to know about the domain. What's the domain of every quadratic? Always. If you miss that part, We will try to work on you getting better. All right. The range is dependent on what? A. A being positive 1 told us that this graph opened which way? Up. So it's doing this. So where's our range going to start at? At the bottom, right? What's the minimum y value? Negative 1/4 from the vertex. So it starts at negative 1/4 and goes up to positive infinity. And it does the negative 1/4 included? Yes. So square bracket on that guy. All right. Now, we'd be remiss if we did not look at the graph of this. So let's use that nice fancy $100 calculator we got. And let's look at the graph of that. So this is also helpful in getting rid of the problems that you'll have when you do a linear regression and then you go back to do regular math. So here's what we got to do. Hit y equals. If you've got any equations in there, clear them out. Just go down to that problem and hit clear, and it'll get rid of it. Now, you'll notice up there at the top, I've got plot 1 darkened in. I don't want the plot on. It tends to cause tons of problems when you go to graph regular equations. So we want to turn that off. The quick way to do that is just press the up arrow key and see when it's blinking, hit enter, and now it's not darkened in anymore. And that turns it off. And just make sure you got your plots turned off and then type in the equation. We got x squared. X is right there beside the green alpha button. Squared is right above log. Plus 7, and then another x, and then plus 12. And I'm going to hit graph, and I'm going to have to do something else to get my picture to look right, because I only see part of the graph. Zoom 6 to go back to the standard window. That gets you, man, a good-looking parabola there. Where is it crossing the x-axis? -4, -3. We see that there. We see its vertex right down here just below the y-axis, -1/4, just below the the y-axis there. So we see all those things. It's opening up. We get the picture of it. Okay. If we were able to fold that screen right across the middle, we'd see that axis of symmetry happening. Okay. All right. So that's standard form. Wonderful standard form. Let's look at the next form. Vertex form. Vertex form, also called shifted form, if you, depending on where you go to school. The vertex form is what I've always called it, but I've seen it in books called shifted form. Vertex form looks like this: f of x equals a parentheses x minus h squared plus k. It's a wonderful form for some things. It's not so nice for other things, but it's pretty nice for a few things. Makes a little bit more work on the others. So each form has its own strengths and weaknesses. With the vertex form, what do you think is the strength of a vertex form? It hands you the vertex just on a silver platter. It says, here it is. Okay? So all of that stuff about A still applies. That's the same A. So if A is positive, it's going to open which direction? Up. If A is negative, it's going to open down. So all that stuff about A hasn't changed. What has changed is how you have, what you have to do to find the vertex. And technically the axis of symmetry. So I should have just said axis of symmetry first, because that's what we did first a while ago. Axis of symmetry, x equals, and instead of having to do negative b over 2a, all we got to do is find out what h is. And that's the axis of symmetry. Man, there's no work involved. The vertex, well, if the axis of symmetry is h, then the x value of the vertex has to be h. The y value of the vertex, it's right there. It's k. I don't know why I changed the way I wrote a k, but k. HK is the vertex. We'll look at one with numbers in it in just a minute. All right. Maximum or min on that, still dependent on A. Don't lose that idea. All right. Intercepts. How do you find the Y-intercept? It's not as easy on this one. You know, when it's in standard form, it was always just C. With this, it's not that easy. You got to do some work. You're going to find f of 0 and work it out. You just plug in 0 for x and work it out. That's how you find the Y-intercept. X intercepts. How do you find X intercepts? How did we find it when it's in standard form? Still going to do the same thing. You're just going to set a x minus h squared plus k equal to 0 and solve. And we'll do one with numbers in it so we can actually do something here. All right. Domain. What's the domain of every quadratic? Negative infinity, positive infinity. The range. Depending on the A value and the vertex. So from k to positive infinity, A would have to be what kind of number? Positive. And from negative infinity to k, the other way around, negative. That's the way the range works on that. Get a few things for free there. So let's look at an example and find all those same things that we did for example A, but from one in vertex form, and see if we can get there. All right, so example B, g of x, 2 parentheses x minus 3 squared plus 4. All right. Axis of symmetry. I'm going to abbreviate because I'm getting tired of writing that down. Axis of symmetry. Well, here's the thing. We got to, instead of finding the list A, B, and C, let's do H and K. That seems to be pretty common on this problem. What's H? Almost.
Oh, it's just 3.
It's just 3. The minus sign is standard in there. So we take 3. And K, in this case, would be 4. Positive 4 because it's a plus 4 on the outside. And in the form we're given, it's always the opposite inside there and then the same thing on the outside. So the axis of symmetry for this one would be x equals what? 3, the h value. The vertex three, 4. Is it a maximum or a minimum? Minimum. Why? A is positive. A is 2. So it's going to open up. Okay. Let's find our intercepts. Y-intercepts. Pretty easy, right? Maybe. And g of 0 here. Plug it into the function. Work it out. Be 2 times negative 3 squared plus 4. Negative 3 squared is 9. 9 times 2 is 18. Plus 4 is 22. 0, 22. Finding the X intercepts, if they exist. So we're taking the equation and setting it equal to 0. Factoring is possible here, but not a good way to go about doing things. Quadratic formula, possible here, but we got to do a lot of work, pre-work, for us to use the quadratic formula. If we were going to use the quadratic formula, we would need to work this out to get it into standard form. That's a lot of extra work. So we want to try to solve this a different way. And that different way is using square roots is the quickest way. If it's in vertex form, solving by square roots is the quickest way to get your x-intercepts. So let's do that. So to solve by square roots, the rule is get the square part by itself. What part is the square part in that equation? X minus 3. Get it by itself. So we subtract 4. We divide by 2. Once I get the squared part by itself, I can take the square root of both sides. And that gets rid of the squared and leaves you x minus 3 is equal to plus or minus I radical 2. What do we know about complex solutions on the x-intercepts? Do they show up on the graph? No. That means this is not going to cross the x-axis. So there would be no x-intercepts. We can go ahead and solve that because we're going to have to in the future anyway. So let's go ahead and get x by itself just so it's not so foreign to us later on. X equals 3 plus or minus I radical 2. Those are the solutions to the equation, but they don't show up when you graph it because they're complex. Complex solutions don't show up in a Cartesian plane. Well, way you want to say that. All right, so what's the domain? Yeah, don't miss that part. It's too easy. Range. What's the range on this one? Yeah, k to positive infinity. 4 in this case is k. And we include that with a square bracket. We could look at the graph of that. I'm going to clear out that other one. I'm type in that equation 2 parentheses. Right above the 8 and the 9 is where your parentheses are. X minus 3 squared and then plus 4. Hit graph. And we see that parabola opening upward, not touching the x-axis because we didn't have any x-intercepts. We can imagine that way on up there, somewhere around the ceiling is 22 on the y-axis, and that's where it's crossing the y-axis at. We can see that it would hit the y-axis way on up there. If you really wanted to see it, you could hit zoom and then zoom out, and it would get you a picture showing that. Okay, all right. So that's vertex form. We have one more form to talk about here. And then we'll get into that building a quadratic. So next form is what's called intercept form. Vertex form made the vertex really easy. What do you think the intercept form is going to make easy? Intercepts. Very, very easy. Okay. So you also might hear this called factored form. Factored form, intercept form, the exact same thing. So if you're dealing with a quadratic function, we know it's quadratic because it'll have, if you were to multiply it out, you'd get factors that x times x is x squared, and that'd be the biggest power of x that you've got if you were to multiply that out. But that's what it looks like. That a that's in front of it, guess what it does? Same rules. Nothing's changed about that a. Okay? Now, there are a few shortcuts to this, and we'll talk about those. I'm not a big fan of the shortcuts, but I don't want to not show them to you. Axis of symmetry. You can get it by adding the two numbers there. M and N are just numbers. Here. Those are just numbers. If you add those together and divide by 2, you got the axis of symmetry. And then the vertex you just take that, whatever that number is, plug it in to the function and get the vertex out of that. The intercepts, still, you know, same idea for a Y-intercept. What are you doing? Plug in what for X? 0. So that ends up being A times M times N. So the shortcut is that you just take A times M times N. I don't really use these shortcuts, but they're part of your curriculum, so I'm showing them to you. I always just do it the other way. But we'll do it. When we do an example, I'll show you how you really do it. X intercepts, this is where the intercept form shines. This is why it exists. X intercepts, that's the important intercepts anyway. When you're doing with quadratics, polynomials, X intercepts are where we try to find everything going on. So you set the whole problem equal to 0. Technically, you divide by A, and you get X minus M, X minus N equals 0, because anything 0 divided by anything 0. And then you set X minus M equals 0, X minus N equal to 0. Solve those, it just changes the signs. So your points are M0 and N0. So the intercepts, the X intercepts are easy in the intercept form. Okay. All right, let's look at an example. Domain and range, still the same stuff. Nothing's changed there. Domain and range, all the rules still the same there. So let's look at an example and actually do some stuff with this, because the work is not that difficult. The theory of it can get confusing, but once you do a problem with numbers in it, it's not too bad. Bless you. All right, so let's find the axis of symmetry. Just like, you know, everything's the same. We're doing all the stuff here. Axis of symmetry. X plus 7 and X minus 8. Okay, so M and N are what we need to know. So here's what I do. Okay, and I know I'm finding axis of symmetry, vertex, and intercepts. I'm just going to use, since it's intercept form, I'm going to go get the X intercepts first, because that's the easiest part of this. Okay, because if I get the X intercepts, what do I have? I have M and N, and then I can use those shortcuts, right? So I'm going to set -6, X plus 7, X minus 8 equal to 0. I would divide by -6 just to get rid of it. Set each of those factors equal to 0. It changes the signs. My X-intercepts are at -7, 0, and 8, 0. The axis of symmetry now, since the -7 is M and N is 8. Okay, that's what I'm finding when I find those X-intercepts, is M and N. Okay.
So we can't just look at the first,
You can,
but it's not the same.
well, you got to change their signs. And that's where, you know, if you change their signs, you're really finding their X-intercepts anyway. So that's why I'm doing that there. So
Just change the signs on the intercept form, or did we do it on
if you factor the standard form, you won't change signs. But we don't change signs for H and change signs for H, but not K on vertex form, and on standard form. If you're using quadratic formula, you don't change signs. Okay? So where the sign change comes is from solving this. You subtract 7, get it on the other side, and that's why it changes signs. That's the why. So if you never move it to the other side, you don't change signs. Maybe that's a better way of answering. Axis of symmetry. Here's what's going on, guys. You got this parabola drawn that's going here, and that axis of symmetry, you know, this thing is crossing the x-axis at 8 and -7. Halfway through there is where that axis of symmetry is at. So really, the x value for the vertex or the axis of symmetry value is halfway between there. It's the midpoint of those two x values. If you remember midpoint formula, probably used in a geometry class, but for like a week, and then you never touched it again. But midpoint, just add them up and divide by 2. That's where that trick is coming from. -7 plus 8 divided by 2, which would be 1/2. So the vertex is at 1/2 something. We got to find something. Did I do something wrong? Okay. Crank out that answer there. I don't know. I'm going to go -6 parentheses 1/2 plus 7 parentheses 1/2 minus 8. There. And I'm going to hit math, enter, enter. Ooh, 675 over 2. Which as a decimal is 337.5. So way on down the line there. Definitely going to be off the screen when we graph that thing, right? Pretty easy to tell that. All right, so there's our vertex. There's our axis of symmetry. Our intercepts, we've already got the X intercept, so all we've got to find is the Y intercept. Before we do that, is that a maximum or a minimum? A is negative, so that is a maximum. Good job. Perfect. Okay. Y-intercept, plug in 0 for X. That's what's happening. The shortcut is just you multiply -6 times M and N. That's what happens when you do that. Huh? -6 times 7 is -42 times -8 is going to be a positive something. 336. 8 times 4 is 8 times 40 is 330 or 320, and then add 16. No, yeah, 320 plus 16 is 336. You can just type that in. Y-intercept 0. 336. I'd say that's off screen too. We don't want to see that happen when we look at the graph. What's the domain? Yeah. Don't miss that. Range. Oops. Wrong notation there. Square bracket. Negative infinity up to the y value of the vertex. Because remember, this one opens down. Because you got a negative a value. Okay. All right. Let's build an equation. And then we'll swap to using the calculator to help us in a minute. write the quadratic given 3 intercepts. Three 0, negative 5 0, 0 8. Okay. It's still 4 3. 4 4 will be like a quadratic regression type stuff, and then a couple of word problems. It's pretty short too. This is the most difficult of what we're doing today because it just takes more algebra. Okay, given intercepts, which ones go into the intercept form? X intercepts or Y intercepts? When we look at the intercept form, remember intercept form was this. These, the M and N, were the what intercepts? X or Y intercepts? Close.
Would the first 2 points be the X intercept because Y0?
There you go.
And then the last point would be the Y-intercept because X is 0.
There you go. So these two are the X intercepts. This is a Y intercept. Intercept form, the Y-intercept's not real pretty. It doesn't come out real easy. But the X intercepts do. So if you're given X intercepts, then you want to start in intercept form. If you're given a vertex, what form do you think you want to start in? Vertex form. If you're given a Y-intercept, what form do you think you would start in? If you're only given a Y-intercept and maybe a little bit of other information, standard form. You're hardly ever going to start in standard form. You're either going to start in, here we're going to start in intercept form, or you're going to start in vertex form. We'll do one where we start in vertex form next. Okay. So here we're going to start in intercept form because those two are X intercepts. That's the reason we're going to start with intercept form. We're going to get the other two forms, maybe, or at least standard form from there. Okay. Now, because those are X intercepts, that means that I've got f of x equals, I don't know what a is, but I do know that that would be x minus 3 and x plus 5. Change the signs to get them back into the form, into the equation part, right? So x minus 3 and x plus 5. That's intercept form, but a is not in there yet. I've got to find a. What have I not used yet? The Y-intercept. I'm going to use that to find a, okay? Because this is an x value and this is a y value. So everywhere there's an x, I can put a 0, and everywhere there's a y, I can put an 8. Where's there a y? F of x. This is y. So that's 8 equals a, parentheses 0 minus 3, parentheses 0 plus 5. And now the only variable that exists in that problem is a. So that's what I'm going to try to use to get there. So that'd be negative 15a. How do I get a by itself? Yeah, divide by that negative 15, and a happens to be a fraction in this case. Negative 8 over 15. And that's okay, not a big deal. So my intercept form a, the a that we didn't know at the beginning. We knew these parts, but we didn't know what a was. So we used the other point, the third point they gave us to find a. We plugged in 0 for x and 8 for y to get a. We were trying to find out what a was. A is negative. What does that tell us about our graph? It's going to open downward. So we know that about the graph now. Not necessarily true that we knew that beforehand. Maybe if we plotted those 3 points, we'd get the idea that it did open down, but it's not necessarily always going to be that clear. So negative 8 over 15, x minus 3, x plus 5. All right. Now that's intercept form. How do I turn that into standard form? Once you get the first form, the others are just a few moves away. So how do I turn an intercept form into standard form? Well, standard form doesn't have these parentheses stuff in here, right? So how do I get rid of that parentheses junk? What operation does that mean is going on between these two things here? They're being multiplied. So I'm going to multiply those two together. So I'm going to say x times x, get x squared. X times 5 is 5x, negative 3x, and negative 15. I still got a out there in front. We'll take care of that in a second. Once I've done that, I can simplify just a little bit. Get x squared plus 2x minus 15. And then what's left to do to get that in true standard form? Perfect. Distributive properties, all that is. Distribute negative 8 over 15 to everybody. That's negative 8 over 15x squared minus 16 over 15x plus 8. And there is standard form. All right. Now, the fun one is vertex form. And if you were in my Algebra 2 class and we had about a week here we could work on this, I'd make you learn how to complete the square, turn it into vertex form. And I saw eyes get big there. So got as big as the McDonald's cup there. That's not a fun thing to do, complete the square. If you've done it before and you caught on to it, great. You're one of few in the world that ever catch on to that. But you don't have to do that because all we've really got to be able to find to put it in vertex form is the vertex. And we've got two different forms. We've got intercept form and we've got standard form already built. And we can find the vertex from those and use it in the vertex form. Because remember, vertex form is f of x equals a parentheses x minus h squared plus k. If you don't remember it, you will. Do enough practice with this, you'll get it. You'll need to know that. So gotta start committing it to memory. So we know A is negative 8 over 15. So I know my vertex form is going to start out with that. And I just got to fill in the stuff here. So how do I find the H and the K for that? This is where it ties it all back together. Remember, H is the x value of the vertex, and the x value of the vertex is actually the same value as the what? Axis of symmetry. Somebody say it. The axis of symmetry. Good job. The axis of symmetry. So if I can take negative b over 2a, I'll get the axis of symmetry, which will be the h for the vertex form. Oh, man. All I got to do is find the vertex. So I just got to find vertex. Negative b over 2a. That's going to be the x. So that'd be 16 over 15 divided by 2 times negative 8 over 15. Never fun to divide fractions. I think it's fun to watch people try to do it. But it's not that bad. Because if you multiply 2 times negative 8 over 15, this is really negative 16 over 15. And when you divide by a fraction, it's the same thing as multiplying by the, starts with an R, reciprocal, yeah. So the reciprocal of negative 16 over 15 would be 15 over negative 16. And then that's an easy problem to do. Because the 15s cancel, the 16s cancel, and you're left with negative 1. So that's plus 1 in there. Or it's the opposite on the inside of the vertex form. Now all I got to find is the y value. I think I can plug -1 into that standard form. F of -1, -8/15 times -1 squared minus 16/15 times -1 plus 8. And generally, I like to do things without a calculator. Not today. That's going to be -8/15. I'm still doing it without a calculator because I can't make myself not do it with a calculator. And you work that out. Be 8/15 plus 8. 15 times 8 is 80, and 40, which is 120/15. Is that right? 128/15. Is that right? Did I do my math right, or did I screw something up? If you use a calculator to do that, -5. If you didn't use a calculator, plus 1,000. I'm just kidding. I wouldn't -5. But we got vertex form from using the standard form we built. So that's important to be able to go from standard form to vertex form and back and forth there. Okay. All right. Now let's get one. We start with vertex form. So let's say we're going to write a quadratic, and then I'll show you the calculator thing. With a vertex of 6, -5 through 0, 0, -12. That's a good number. So here, let's just get the vertex form of this, and we'll stop. We'll get vertex and standard form. I won't make you do intercept form on this one because it doesn't work out real nice. Because I just made the numbers up. So vertex. If we get the vertex, we start with vertex form. A x minus h squared plus k. X minus 6 squared plus k. Well, k is -5, so that'd be -5. How do I find a? Jumping around too much there. Sorry. How do I find a? What have I not used yet? Pick me. That guy. I hadn't used him yet. All right. So -12 equals a 0 minus 6 squared minus 5. And all I got to do is just solve that thing for a. So that's going to be 36a minus 5. That's -12. And I would add 5. -7. A is a fraction. Even better reason not to go to intercept form. So a is -7/36. What do we know about this parabola based on that? Opens down, yeah. Has a maximum value at where's the maximum at? At the vertex, at 6, -5. Okay. Now, to get that into standard form, x minus 6 squared means x minus 6 times x minus 6. So this is vertex form. To get into standard form, we got to do this multiplication here. And the most common mistake is folks want to say, oh, that's x squared plus 36. And they're absolutely wrong when they do that. Because you distribute x times x is x squared, x times -6 is -6x, and then you do that again, and then there's the plus 36. Then all you got to do is distribute after you simplify. That'd be negative 7 over 36x squared plus 12 goes into 36 3 times. So that'd be 7 over 3x minus 7 and then minus 5. All this is f of x here. One more step. Get the constants together on the end there. Negative 7 over 36x squared plus 7 over 3x minus 12. And there's our standard form for that one. Kind of ugly, but a standard form for it anyway. Fractions don't make it friendly, but still doable. If they give you a vertex, start with vertex form. Most of the time, if they give you a vertex, all they're asking you to do is find vertex form. They give you intercepts, they're just asking you to get it in intercept form. Okay, that's most of the time all they're asking for. Or at the most, asking, we still got class going on, Miss Wanda. All right. So we need to take that to, if you needed to take that to intercept form, it would definitely be better numbers than that. This one would be borderline impossible for us to do that with because the fractions in it. It's not factorable. All right, now let's look at section 4.4, and I've got a PowerPoint kind of built for that, and I'll post these slides on Canvas so that you don't have to copy them down. If you want to take pictures of them with your phone while you're doing it, I don't care. But I'll post the slides on PowerPoint in PDF form so that you can open on anything and not have to worry about it. We're going to build quadratic models from verbal descriptions. All right, so let me start the presentation here so we can get to the right things. All right. A farmer has 2,000 yards of fence. 2,000 yards of fence to enclose a rectangular. That doesn't make. Yeah, 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that enclose the most area? So we're going to maximize the area because I said most. If you're looking for a maximum, what part of the quadratic are you looking for? The vertex. If they're looking for a minimize or minimum, you're looking for the vertex. That's the big thing we got to take picture. We got to take from this. Okay, so we've got a rectangular field. So envision in your head a rectangle, and we don't know the dimensions of that rectangle. We want to maximize the area. So what's the formula for area of a rectangle? Length times width, right? Yeah, length times width. So A equals length of width. All right. We don't know the length and the width of our rectangle, so we'll call this X, and then this length we don't know that much. But we know those two together. And then this would be how much? I've got a better drawing here in the PowerPoint. Let me pull that up. There we go. I'll put X up here and W's on the side. Doesn't matter. Okay. Available fence. So we got a fence. Evidently we've got corn in there. Perimeter of the rectangle is the key. The perimeter is how much fencing we have. 2x plus 2L plus 2W, 2x plus 2W. It doesn't matter what letters you use there. But the perimeter formula has also got to be involved. Got to know those formulas. Perimeter formula, 2 times the length plus 2 times the width equals perimeter. The area formula, length times width, we're calling length x here. Doesn't really matter there, okay? So when we set that up, we've got stuff going on. We can take this equation here and solve it for one of the variables. I want to solve this thing for W, so I've got something with X in it. Okay? So taking that equation, get W by itself. So we move 2X by subtraction. Then we take and divide everybody by 2. 2,000 divided by 2 is 1,000. 2 divided by 2 is 1. So W is 1,000 minus X. So we found that missing side that we didn't know about. All right, 1,000 minus x. Now the area, remember, was x, or length times width. Our length was x. Our width was now 1,000 minus x. We multiply that together. Guess what we got? What kind of equation is that? Quadratic. It's in what form? Standard form. How do we find the vertex of something in standard form? Well, we first got to find the x value of the vertex. What's the formula for that? Negative b over 2a. Negative 1,000 divided by negative 2 would be positive 500. Okay? All right. If we graphed it, we'd see that going on. We'd see the vertex up there at the top. Our graphing calculator, we'd have to zoom out a bunch of times to make that happen, right? We don't want to do that. We want to use our formula, negative b over 2a, to get there. Here's our formula. 1,000 divided by 2 times a, negative 1,000 divided by 2 times a is positive 500. That's the x value. We then plug that back in to the quadratic that we had, negative, then 500 squared times or plus 1,000 times 500. We get 250,000 as the square yards that we could cover. That's the maximum area that we could find. Finding the vertex. If it asks for a maximum or minimum, find the vertex. That's I want you to take that away from this. If it asks for a maximum or minimum, I'm finding the vertex of that. Very simple problem. Be aware how to do one like that. All right, next thing is the calculator deal. Here's the difference in this and what we did with the calculator in the beginning of the class with the linear stuff. One button. It's all the difference. This is list 1. This is list 2, just like we talked about with the linear regression. But instead of picking linear regression with our calculator, we can do a scatter plot. We can see that it's not straight line. It's going to be a parabola shape. We would see that. We can use it to find the equation. Here's our scatter plot. That's what we do. We can use quadratic regression, regression. So on your graphing calculator, you're hitting stat, you'd go edit, you'd put in your lists, and then you'd hit stat, go to calc, and instead of picking linear regression, you're going to pick quad regression because you want a quadratic built out of it. And click that, and it'll give you the equation. And then if they ask you to maximize it, what do you find? Vertex. If they ask you to minimize it, what do you find? That is the only difference in that stuff. Okay? So quadratic regression instead of linear regression. Look at the scatter plot, see what it looks like. And then that gets you what you need there. Okay? There is the equation for that particular situation. A, B, and C, the same A, B, and C from standard form of a quadratic. That's what they're finding. That's what quadratic regression will find. It's A, B, and C from standard form. All right. Here they're maximizing it. And again, this is graphing that equation on the scatter plot. You see that it, where it follows. All right. Next week, we got our test. Your Canvas quiz for this week will be online. Should be before I leave here tonight. I will also post a PDF of a practice test that for the first exam covers chapters 3 and 4 that we've done so far. I'll put a practice test out there. It won't be exactly like the test you're going to have. It'll have similar problems to it. Numbers will will always change to that, but problem style will be the same. Your test will be multiple choice. Your practice probably will not. Practice will be short answer style.
Would you say you'll have practice?
I should have it up tonight too. It'll be all that'll be on Canvas. I'll post an announcement with a link to today's lecture and that PDF in there as well. Okay. If you got questions, please email, ask. I will help as much as I can.